Hello, everybody. Hey, this is a video on help with week 5 worksheets. And those week 5 worksheets are going to be motion 5.3, 5.4, and 5.5. So 5.4 is motion number 8, and 5.5 is going to be motion number 9. So here are the numerical answers. Those are the numerical answers. And what we're going to do right now is to go over a few of these questions in each of the worksheets, so you'll have an idea of how to do that. So the first one we're going to do is 5.3, 5.3 number 2. All right, so if you've looked at the lecture acceleration number 3, you'll see these. So remember, these are our 4 kinematic equations, and they can be rearranged. So on worksheet 5.3, there's a bunch of these equations, and some of these are broken down into more than one. Okay, so for example, equation number 2, okay, and acceleration, these really are the same. These are the same thing. Okay, so you guys, we are going to start with 5.3 number 2. So in 5.3 number 2, what will be the displacement of a train moving with an initial velocity of 12 and a final velocity of 26 if it takes 14 seconds? Okay, and we're looking for the displacement. Now, remember, going back to these equations here, we're not given an acceleration. So if we're not given an acceleration, then we're going to use this first equation. Now remember, this first equation, average velocity is equal to displacement over time and v final plus v initial over 2 if it's accelerating. And since it's changing velocity, we know it's accelerating. So the first thing we're going to do is we're going to solve for the average velocity. So our final velocity is 26, our initial velocity is 12, and then we're going to divide by 2. 26 and 12 is 38, divided by 2 is equal to 19 meters per second. So that is our average velocity. That's not the answer to our question, because our question wants displacement. But now we're going to use this equation, but now we're going to solve for d. So average velocity is equal to distance divided by time. We're going to rearrange this, and we're going to say distance is equal to average velocity times time. Okay, so we know our average velocity is 19 meters per second, and our time is 14 seconds. 14 seconds. And when we multiply that, our displacement is going to be 266 meters. All right, so that is 5.3 number 2. Now the next one we're going to go to is 5.3 number 5. Now 5.3 number 5 is kind of the same thing in reverse. Same thing in reverse. It takes a car 4 seconds. So 4 seconds to come to a final velocity of 0, okay? And if the displacement was 15 meters, what was the car's acceleration, okay? Now, we do not know what the initial velocity is, okay? So we're actually going to use this up here, okay? And we're going to determine what the initial velocity is, and then we're going to use that into the second equation. Okay, so it's kind of like the reverse of what we just did. So now we know that average velocity is going to be displacement over time. So we're going to have 15 meters over 4 seconds. And we do the math there. Our average velocity is going to be 3.75 meters per second. So now we're going to say average velocity is equal to v final plus v initial divided by 2. So we know that this is 3.75, and we know this is 0 plus our initial velocity, which we don't know, divided by 2, okay? And now we can multiply both sides by 2. This side cancels out. 3.75 times 2 is 7.5 meters per second, and that is our initial velocity. Okay, so now we know our initial velocity is 7.5 meters per second. Now we can go and solve for the car's acceleration, okay, by using equation number 2. So V final is equal to V initial plus AT. So we know this is 0. We know this is 7.5 plus A, and we know our time is 4. We're going to subtract both sides by 7.5, negative 7.5, okay? So negative 7.5 is equal to 4A. Divide both sides by 4. And we're going to get an answer where our acceleration is negative 1.9 meters per second squared. Okay, so that is 5B. All right, so the next problem we're going to do is 5.4, number 3. 5.4, number 3. That's also motion number 8. So 5.4, number 3. Remember, this is motion 8. All right, so I'm going to get rid of these, and we will start over here. All right, so a ball is dropped from the top of the Valhalla gym. Okay, now if you drop a ball, okay, on near the surface of the earth, you know that the acceleration is equal to the acceleration due to gravity, which is equal to 10 meters per second squared. Now, one way to make this a little more consistent is we're going to say up is positive and down is negative. So if we stay with that consistency, then we know that this g is actually negative 10 meters per second. All right. The other thing we know with that is we know that the initial velocity is 0 is because we dropped it, okay? And then we also need, or we have the time of 3.5 seconds, 3.5 seconds. And the question is asking is what is the velocity of the ball the instant before it hits the ground? Okay, now, once it hits the ground, right, it's gonna stop. But we're talking about what is the velocity as it hits, okay? So you know that if you were at the bottom and it hit you, it would not have a velocity of 0. So that's what they mean by the final velocity. Okay, so now we can use equation number 2. Okay, so we can say V final is equal to V initial plus GT. Now I put GT because I know it's dropping. We could put AT. We know they're the same. So we're going to say V final is equal to 0 plus negative 10 times 3.5. Now you guys may remember from that lecture number 2, acceleration is really 9.8, but we're making it 10 to make it easy. And we can see V final, 10 times 3.5 is 35. We're going to put a negative in there, and that would be meters per second. Okay, we could also say 35 meters per second, and we can put our direction as down. Okay, and both of those would be good answers. Okay, you guys. Now we're going to go to motion number 9. Motion number 9, and a lot of worksheet number 9 is to building on each other. So I am going to do 3A, B, C, and D. And we'll see how all of those are related. There is no number 4 on there unless it gets fixed, okay? So let's go back to so this is going to be motion number 9, which will work out to be 5.5, okay? So 5.5 or motion number 9, problem 3A. So we're going to start with A. A soccer ball is kicked straight up from the ground into the air with an initial velocity of 22.8 meters per second. Okay, so we know that the initial velocity is equal to 22.8. 22.8. So kind of draw a little picture here. Okay, the ball is going up into the air. We are given a time of 3.18 seconds. And what's the acceleration? Well, remember, we're kicking the ball, and for kicking the ball, it's going to be up in the air in free fall. So we know that the acceleration is equal to 10 meters per second squared. And again, we're going to call up positive, therefore the acceleration, which is you can also call as G, is negative 10, okay? So you guys, we want to know where it is. So that's going to be the displacement. The displacement is equal to VIT plus 1/2 AT squared. All right, so we know that this is going to be 22 times 3.18, okay, plus 1/2 of negative 10 times 3.18 squared, okay? Now, if we do the math there, okay, our answer is going to come out to be 21.9 meters, 21.9 meters. And that's going to be equal to the height, okay? Because this is where we started, and then it would end up here. So that displacement is 21.9, okay? All right, 3B, and I'm just going to change colors here. And we're going to say 3B, because 3B is very similar. And all it's asking is, hey, where is it when the time is 5.10 seconds, 5.10 seconds. Again, same equation here. So now we're going to go down and change the time here, 5.10, and over here, 5.10. And when we do the math, okay, on your calculator, it's going to be negative 16 meters, okay? But does that make sense? And the answer is it doesn't make sense because we threw it off the ground. So it would have gone up to a certain height and then come down. So if it were allowed to go through the ground, it would have ended up at 16 meters below the ground. So our answer really here is 0, okay? So our displacement is 0 for 3B, okay? You guys will see in 3C and 3D kind of how this sort of makes sense. So again, you guys, I'm going to change the colors here, and I'm going to do 3C, and we can just change everything. What is the velocity of the ball when it's 17.5 meters off of the ground? Okay, so we want to know what is the velocity, and I'm going to change a few things here. Okay, so now we have a displacement of 17.5. We know our acceleration is still gravity, which is -10, and we want to know our final velocity. So notice here that in 3C, we do not know the time. We don't know the time. So if we go back to these equations here, and in equation number 4 is an equation when you don't have time. So we're going to use equation number 4, and that's going to be v final squared is equal to the initial squared plus 2ad. Okay, so now we know that this is 22 squared plus 2 times -10 times 17.5. Okay, and that's equal to v final squared. So you guys, when we do the math there, we're going to end up with this as being 169 point something meters. And that is equal to v final squared. So if we want to get rid of the squared, we're going to take the square root. We're going to take the square root of both sides, and we're going to get v final is equal to 13 meters per second. Okay, so that could be, all right, so that would be, it could be plus or minus. That could be plus or minus. And we're going to kind of figure that out here in a second. Because remember, as it goes up, okay, it's going to be, if it goes higher than 17.5, okay, it will come back down, and at any level, as long as it's at the same level, it's going to have the same. It's going to have the same velocity. Okay. Now, finally, we're going to get to 3D, and 3D is how long is the ball in the air. So again, I am going to switch colors here, and we're going to get to 3D. Okay, so our initial velocity is still 22. Our acceleration is still -10. And we are looking for time. So this is our question mark. Okay, now, if it goes up into the air and comes back down, okay, our displacement, the difference between where we started and ended, is going to be 0. Okay, so that's kind of a tricky little thing there. Now remember, and I don't think I mentioned it here, but if we can find 3 variables, 1, 2, 3, we can solve for any of the other variables if we use the right equation. Okay, so our right equation is going to be the one where we don't have a final velocity, and that is going to be equation number 3. So we'll plug this in here. D is equal to VIT plus 1/2 AT squared. So remember, it goes up and down, so that's going to be 0. 22 times t plus 1/2 of -10 t squared. All right, so what we're going to do here is we're going to move this 22t to the other side. So we're going to do that by subtracting both sides by -22t. And we're going to get -22t. This will cancel out, will equal 1/2 of -10 is -5t squared. Okay, so at this point in the equation, we can cancel out a couple things. We can cancel out the 2 positives there, okay? And one of these t's will cancel out with one of these t's. So we're going to end up with 22 is equal to 5t. We're going to divide by 5. And we are going to get 4.56 seconds is equal to the time. So you guys remember that we